Example 9 is going to show us how natural logs and derivatives go together with the absolute value. So notice that for f of x, this time we have the natural log of the absolute value of x. And what we discover here is going to pay dividends down the road whenever we start doing some antiderivatives, when we're working all this stuff backwards with integrals and stuff. All right, so of course we don't have a derivative rule for natural log of the absolute value of stuff. That's basically what we're trying to do here. So I'm going to rewrite this as a piecewise function because, let's see, it's like this. F of x is equal to two different pieces. Well, if x is already a negative number, then the natural log of the absolute value of x is just that, as long as x is greater than 0, if it's already positive. Now, we don't have to worry about 0, of course, because it's not defined for 0. You'd have a vertical asymptote there. And then, well, what if x was already negative? If x is already negative, to make it positive, you take the opposite of it, which will look like this: the natural log of negative x, as long as x is less than 0. And of course, you don't define anything for 0. All right, then, maybe add an extra little page here. And now let's take the derivative of this piecewise function. We'll just take the derivative of the top, and we'll take the derivative of the bottom part. All right, here we go. F prime of x is equal to, what's the derivative of the natural log of x? It's 1 over x. And again, its domain part is going to be x is greater than 0. All right, and then let's see, what's the derivative of the natural log of negative x? Do a u prime over u. It's a negative 1, that's the derivative of negative x, over negative x, which will simplify to just 1 over x. Oh my gosh, it's exactly the same as the top part. What does that mean? It means that whenever you have absolute values in here, it's going to expand out the domain of this. For sure, it's going to allow you to include negative numbers. But as far as the derivative goes, it's still 1 over x. Now remember, whenever we talked about this function, I'm going to switch colors here, maybe, purple. When we talked about this function, the natural log of just x, we said its domain is x is greater than 0. And when we took its derivative, we said it's 1 over x, where the domain is still x is greater than 0. All right, so if I were to draw myself a little graph of 1 over x, there's actually two branches for this. There's this branch over here in quadrant 1. There's also this branch over here in quadrant 3, right? But for this purple function, for this purple function right here, we ignored this branch down here at the bottom, and we only focused on this one because it was the only one that was important. But now, whenever we stick the absolute value in here, we only take out the number 0, so it's both positive numbers and negative numbers, and then we get the entire graph, both branches of this hyperbola for its derivative. That's pretty interesting. Oops, spoilers with the graph. All right, so there's exactly what we just did right there with the piecewise function, and here is the original function is in pink. That's what the, let's say the natural log of the absolute value of x would look like. Looks sort of like a flying bird or whatever, except for you have a vertical asymptote right there. And then the derivative is just 1 over x. It's both branches of that hyperbola. So then, that brings us to derivatives with absolute values. Looks like this. If you use a differentiable function of x such that u is not equal to 0, then the derivative with respect to x of the natural log of the absolute value of u is equal to u prime over u. And like I said, I'm going to make a promise to you that this is going to come back to us whenever we start doing antiderivatives, working with logarithms with integrals, and finding the area underneath the curve.